Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology. We are learning the subject Basic Electrical Engineering, and in our last session we have been discussing about the electrical installation, wiring and safety. Now in our today's session we are going to talk about safety precautions during the electrical installation. So let us first straight away check the topics, the components of LT switchgear, where we already discussed about the SFU, MCB, ELCB and MCCB. Also we have discussed wires and cables, earthing and its types. In our today's session we are going to discuss about the safety precautions of electrical appliances, types of batteries and their characteristics, and elementary calculation for energy consumption and basics of power factor improvement. So let us first start. I just want to narrate here what are the different safety precautions for electrical appliances. So we'll start with the point number one. The electric shocks are usually received and can be easily avoided by being careful. Great care should be taken against the electric shock while working on the line, whether its conductor is insulated or bad. So you need to check the conductor is properly is insulated or not. Never work with the bare feet. Always wear the rubber shoes while working. In case of electric shock, when a victim is still in contact with live wire which you cannot immediately switch off, insulate yourself on a dry wood or any other insulating material to release the victim, right? So immediately you do not have to react, but you have to wear uh, anti-electric material like insulator material, and then you have to switch off the supply. Use safety belt before starting the work on electric pole or tower. The ladder should also be held by another person while working on overhead lines so that it may not be slip away. More precautions like phase or positive wire should always be connected through the switch. Before energizing before energizing the line, check that there is none working on a main line. Before replacing the blown fuse, always switch off the main switch. Before taking a table fan or portable appliances from one place to another, disconnect it from the supply. Do not disconnect the flexible wire of an equipment from the socket by pulling it out. Do not touch electric installation without any purpose. Overhead lines should never be touched unless you are sure that it is dead and properly earthed. So these are what the precautions, where it's a routine precautions. So one or another way we already experienced most of these electrical appliances precautions, or all these safety precautions while we operate the electrical appliances. Like before starting the work, ensure that you are authorized to do the work. Do not tamper any electrical protective or interlocking gear unless you are authorized. So these are the very common safety precautions while you take care during any electrical installation. If we talk about the power factor, so what do you mean by the power factor? So that part we already learned during our AC circuits. So here, what is the definition, or one of the definition of this power factor is nothing but the cosine of the phase angle between the supply voltage applied to the circuit and the current flowing through the circuit is known as the power factor. So it is denoted by cos phi, and another definition is nothing but cos phi is the ratio of resistance to the impedance. In my way, if you talk about the power factor, is one of the it is defined as the efficiency of any circuit, right? So as part of the electrical designer, always look the circuit would be more resistive. So if circuit would be more resistive, that means the overall offered impedance would be towards the value of resistance. Why? You can achieve a higher value of power factor, that is up to 1. So here the power factor ranges from 0 to 1, right? So as a electrical designer they always try to design any electrical or AC circuit that must have power factor is close to 1. So this is what you can achieve a maximum circuit efficiency. Now we can also discuss about the third definition. So it is also defined as the ratio of active power to the apparent power. So it defined as a cos phi. Now, what are the disadvantages of the low power factor? Right. So if it is a disadvantage, that means most of the power will be lost during the operation, like large cross section area of conductor. So if you take the large cross area of conductor, the wires, that will also have the low power factor. Higher I square R losses, there is a heat losses, lower efficiency, less voltage at terminal, poor voltage regulation, as well as reduction in kilowatt capacity. Right. Now causes of a low power factor. What way you will find a, you will calculate a low power factor, like induction motor, agriculture pump set, arc furnace and induction furnaces, arc lamps and electric discharge lamps, arc welding, overheating of any equipment, that will also cause the low power factor, increase in a system voltage, right? Same way, uh, what are the advantage of the power factor improvement, like small cross section area of conductor you have to use, then you should go for an increased kilowatt capacity, reduction in heat losses like I square into R, higher efficiency, better voltage regulation and low running cost. So how to achieve this advantage is to improve the power factor. So we are using a different method. Like one of the method we define is using the high power factor motors, using phase advancer with induction motor, using capacitor booster, using static capacitor and using synchronous condenser. These are the different methods. So somehow those kind of component you have to use in an electrical circuit, in a AC circuit, such a way that that will reduce the more impedance level or reactive effect of reactive parts, and that will add somehow more resistive part in operation of the circuit. So by that way you can improve the power factor. Right. Now let us discuss about one of the important calculation, that is our routine calculation of our home appliances at our home, our home appliances. So in general we can consider as a normal calculation for energy consumption. So let us discuss this example. Let us say in any bungalow has a following load connected to it, like all these 7 different home appliances are available and with their operating or hours capacity. Like one of the component is having the watt capacity is 40, and in one bungalow it is employed around 12 numbers of tube light and working daily 4 hours, right? So one of the component we define as a 40 watts of tube lights, 12 numbers and switched on a 4 hours per day. Second component having the 60 watt ceiling fan, 7 numbers in a bungalow and switched on for 6 hours per day. Same way, the 100 watt 160 liter refrigerator switched on 12 hours per day. 100 watt of television set switched on for 5 hours per day. 40 watt of computer switched on for 8 hours per day. 500 watt of air conditioning 2 numbers switched on for 6 hours per day, and 100 watt of water pump switched on for 2 hours per day. So what would be the rate of monthly electricity bill of that particular bungalow which employs all this electrical appliances, and you consider the energy cost is 5 rupees per unit. So let us start and calculate electricity bill for this bungalow. So we have total 7 items. Then what are the power capacity they are working? So these are the wattages they are consumption throughout this home appliances. Number of units in a bungalow. Then how many hours per day they are operated, they are running, they are on. Based on this we can find the energy consumption in watt hours per day. So if tube light having 40 watt specification or 40 watt tube light of 12 numbers and operated at 4 hours per day. So what I am going to do, I am going to multiply the total consumption, total energy consumption in terms of the watt and hours. So 40 multiplied by 12 multiplied by 4, you will find 1920. Likewise, you can go for ceiling fan. 60 watt ceiling fan, 7 numbers, and operated for 6 hours per day. So that the per day consumption in terms of the watt hour is 2520. Same way for a refrigerator, the per day consumption is 1200. Television set, the per day consumption is 500. Computer per day consumption is 320 as per the given specification. Refrigerator, two numbers, per day uh, energy consumption in terms of watt hour is 6000. Water pump is 200. So what is the total daily power consumption we found here? And that is 14460. Now this is a watt hour. Now I have to convert into kilowatt hour, and this kilowatt hour is nothing but it's a units, right? So if I consider the total energy consumption per day, this is in a watt hour, but in convert into a kilowatt hour, so you have to divide by 1000 when 14.46 kilowatt. So monthly energy consumption, if you talk, the number of days in monthly is 30. So 14.46 multiplied by 30. So the monthly energy consumption in kilowatt hour form is 434 kilowatt hour or units. So here is already given the cost of energy is 5 rupees per unit. So once we multiply this 134 kilowatt multiply by 5, you will find the monthly electricity bill for this bungalow where all the home appliances are working as per the given requirement. Then the monthly electricity bill is 2170. It's a 2170 rupees. By that way you can easily calculate of any home appliances of the power consumption. So you can easily calculate energy consumption of any home appliances or any particular house, right? So this is what about the safety precautions during the electrical installation, as well as the how you can improve the power factor, and how you can calculate the energy consumption bill by using this electrical appliances. So thank you dear students. If you have find any difficulty, please write in the comment box.